Good night. So this will be a microscopic examination of two slides. One color is the blue methylene, blue one else in white, respectively from the salt water electrolysis chamber and the tap water. Again, the tap water also I've added a little bit of salt water yesterday. After I've seen that it increases conductivity in a very noticeable way, even more than expected, and much more than just by adding salt, like table salt, to the mixture. So yesterday, not yesterday, this morning, the electrolysis continued for some time until just, it was eroded. No, the rods were eroded, and then it stopped. Again, this is something that it's kind of like, a built-in mechanism with electrolysis that after some time it stops because of the erosion. Unless you use metals that are not eroded or almost not eroded, you need to pick for that purpose metals that are, different metals for both rods actually. Not necessarily so, but and it's not. This is all of this is not of great consequence to us now. Again, I remind you something that I've spoken about quite a bit. That in order to energize neurons with the electrical pathway, as I call it, I use only electrolysis. Since more than a year ago, more than that, since March or April 2023. And I've had, I think, very nice achievement with that. But it's a great question. It's a good question. What actually is going on? Because many things are going on when you do electrolysis. These, arguably, it's kind of this disadvantage of the procedure that is very cumbersome and affected by all sorts of things that are not easy to identify and isolate, especially with my limited background and even more than that limited assets and conditions. But it's also an advantage. It might be an advantage of the electrolysis. If but in order to establish that, we need to understand what's actually happening. And this is discussed in many videos. It's not the time right now to extend on this issue. I just remind you that there are at least four processes, I would say, that are involved. Each might be very significant. One is what you call electrolysis. Like the electrolysis within electrolysis, which means basically separation of H2O to H2O2, H2 and O2 near the two poles. Electrolysis can be used and is used in the industry for separation of other molecules, but this is the most common thing. It's the first usage and the most common usage, and since my mixture usually contain some amount of water, usually you see it happening. And how do you see it happening? Because of the bubbles. Because the oxygen and the hydrogen are formed in bubbles near the two poles. Probably bubbles that are, the actual bubble I think is probably made of just water or liquid of water and other stuff. And the interior is the gas. And it's highly flammable. This allows us to actually notice, to actually know that there is a current. And unless I connect another component in serial, which I normally do not do, to the electrolysis. Maybe I'll do it today sometimes I do it, very, very rarely. Usually I do not do it. Never mind why, but maybe I'll do it. Because now I have, the Arduino kit that I bought several years ago, so I had it in the storage. So I have יש לי שם כל מיני שמונסטס כאלה של אלקטרוניקה. It's a weird, the breadboard and why, of course I'm not going to use the Arduino, not so soon. Maybe in the future, this will be a nice day. Any day is a nice day in hell. But it will be a warm day in hell, or a cold day in hell, when we can actually connect the stuff to Arduino and, maybe break the internet, break PGP, break RSA, do the nice stuff. I mean, that we plan to do, but we're still not there. But again, we might be close to this point more than, I mean, the audience might actually believe. Again, I think that, I mean, with all due respect, I think that, I mean, even though it sounds outlandish, I think after everything that we've already seen, I think that from the practical perspective, I'm closer now to be able to actually use, I mean, the electrical, computation model. I mean, like the Cauchy model of using electricity as, to implement logical gates with the neurons and an actual computer like Arduino, which is a bona fide computer. I mean, from there, breaking PGP, RSA is just, I mean, it's trivial almost. Like, I mean, the difficult thing is to connect a device or transaction that includes the neurons and use the neural technology, the bicycle mechanism in the portals, the mass portal, the electricity portal, information transfer, but in a way that will also include human computers. I think we are closer to this point, even though it sounds outlandish, and it might not be done today or tomorrow, but we're actually closer to that point, I mean, than actually many other alternative models of computing that, I mean, are known today. I mean, are actually close to being used, in practical way. More than all, I mean, quantum computers, which is kind of like the alternative, to the classical Claude Shannon style computers that are basically every computer of our time. Now again with the algorithm, so we have the bubbles. We use it. So I have a part of the small stuff in the Arduino kits. We have very low voltage LED lights. So maybe you actually connect it in serial to actually prove that DC is actually this is like a DC over air circle, not just by the bubbles of the electrolysis chambers, but also by the light bulb, which is a kind of like a symbol of electricity. In order to happen, we must have like a very, very super low voltage light bulb that I didn't have until now because I don't have. It's difficult to actually buy such stuff in normal, like places like that. I don't have credit cards or can order online. But I have this stuff from like a kit that I bought several years ago. So maybe I'll do it today, and then it must be done in serial, of course. So and use very low voltage because the voltage over the void is very. I mean, the difference potential, like over the void, is very, very low. I mean, but with our construction right now. But maybe we'll do better than before. And again, I mean, electrolysis also causes ionization, which is very important, and it might have a negative and positive effect on the construction. It's difficult to tell because it depends on many factors. It might actually be, helpful, and also galvanization, which is also a factor that might be of benefit or of the, I mean, it's difficult to say. I mean, if it's an advantage or disadvantage. Probably it's an advantage because all sorts of things that are within the water are being galvanized, which means covered with metal. Now, this works best when there aren't like very big things inside the water. Like, I mean, yes, if you want to, אם אתה איזה גרוזיני או בוכרי שרוצה, לא יודע, לצפות כל דבר בזהב, או כמו שהיו עושים באמריקה לפני 130 שנה, או כל הנובורישים, אז בסדר, תשים שם מה שאתה רוצה. But I mean, if you want to increase the total conductivity of the mixture, it's better to probably use a mixture that is full of microscopic life forms. For example, seawater, but also almost any mixture that is used with the Nero that is, that we tell the Nero to create life forms, and we do it a lot. Because then, I mean, yes, not every life form will be suitable for the purpose, yes. But yes, don't forget that we deal with the alien life forms as well. So maybe the microbes, I mean, at least some microbes, I mean, of some sort can be galvanized, which is great. Now, why would we want to galvanize microbes? I'm against cruelty to animals, but these are probably all alien microbes, and also should be noted that it's for good purpose. I mean, for good purpose, it might not be such a bad idea to galvanize microbes, because they will be of usage that way, and they don't feel pain, I think. So we can galvanize the microbes. You know, the earth is full of microbes galvanized. The bowels, the red bowels, like the red bowels here, are full of microbes probably waiting to be galvanized. And then they will be of usage. I mean, right now they are just, life forms that, swim in the disgusting earth, mud, and of no usage. But, I mean, when galvanized, I mean, then there can be of great help to us. In our mission, to be able to actually, create a bridge between two, because what we want to do is to create a bridge between two plates that are not bridged, you see, and we want a bridge, so we will be able to escape from one, so we'll be able to transfer, electrons from one plate to the other, so a bridge is needed. So, actually galvanizing the microbial aliens might be of great help to us, because then we will increase the conductivity of the mixture tremendously. So you can say, okay, so if you are so hung up on electricity, on conductivity, why not just just use bulk of metal? But no, because we still want. The trick is that the neros, like the robots in the mixture, the microscopic gates, should be all around the place, because we use these neros. First we want to energize the neros, to give them energy, and this is done by placing them in a mixture that is conductive, but still allows them to form chains of conductivity, of superconductivity, because actually room temperature superconductors. Moreover, we want as much neros as possible to be able to place themselves as components in the DC circle of the bridge, as resistors on the bridge, because we want to be able, because the bridge is over the void, as you understand. The bridge is created over the void. So the more neros in each side are part of the bridge, the tunnel in the void is actually wider. That is why it was so important to start the experiment with a process of multiplying the neros inside the bowels, also growing them. Because this ensures that the neros that are created are primed to each other. Because if you would have taken, the mixture from existing mixture, like larger container that I have, I currently don't have. I mean, I have one small container, but I would have done it the same even if I had big containers as I've had in other documented exhibits of this experiment. But you want the mixture to be not just full of neros, but full of neros that are primed to each other. And if they are taken from a larger container, they might not be primed to each other. But if they were created in the plates, they must be primed to each other, because it's not mathematically true, but it makes sense that when they are created, they are primed either to siblings or their parents, and not to some kind of other random one. It doesn't make much sense. So if we created a culture of neros in the two sides, it makes sense that they will be primed to each other. And this also was supported by experiments in the past. That's a much better way to create a bridge over the void. Now, one thing that we need to do, and we will do after the microscopic examination, is first to mix everything, to mix every plate in thoroughly, which I've done now after I've taken the microscopic sample, and then take half of each plate, put it in another plate, and fill the other side. Basically, that each will contain half of each. That way, we can statistically close to 50% of the neros will be primed to a nero that is located in the other plate. Statistically, it cannot be more than 50%, and it cannot be 50%, but it can get close to that. And it's closer to that with proportion to how many newly created neros exist compare that to neurons that were there when we started the experiment. Because the ones that were there, maybe they are not primed to each other, they are primed to another one, like in another container or my body or whatever. But the new ones are the ones that are primed to others that are already here. So the more new ones and bigger, the bigger ones that we have with comparison to the ones that were already there, the percentage of ones that are primed to those that exist in the other side after we do the mix, the mix between the two, is closer to 50%. Of course, it can't be more than 50% because, there are trillions or millions or billions, and each one that we pick, can either be primed to this one or to that one. So it's 50-50, and since we pick so many, statistically it cannot be more than 50%. But it can be close to 50% again if the mixture contains, if the proportion, the higher the proportion between the newly ones to the older ones, the closer to us to 50% that will potentially be part of the bridge. Of course, not all will be part of the bridge. This is also related to how much the quantity in the container. That's why in the past I tried to do these experiments with smaller containers, but it's a problem as well because then what you get is very high, very effective electrolysis in the initial stage, and it's not always beneficial. There are problems with it, okay? There are practical problems with using very small containers. So I put this one, they are not that small, but they are not metal, they are ceramics, colored with red to signify human bodies. And they are not that big, but there is a problem with, I don't want to elaborate on that too much. I just say that if the containers are too small, it also, it creates problems. Certainly problems with the visibility component of this experiment, which is important because we actually want to show you that there is a circle online. And I don't know if I'll be able to do it using light bulb. I've never done it until now because I didn't have we need very low voltage light bulb. Now I have it, but I don't know if it actually will be able to do it, maybe. But I think now I couldn't done it. And using the multimeter, it's also problematic. So the best way that I can show you the actual DC over here, and I've done so in the past, is by the bubbles of the electrolysis. But this required H2O content, which it's all, there are also practical problems. So that's why I've chosen containers that are not that small. Of course, when you say small and big, this is compared to the voltage of the transformer, of the DC transformer. Now, I would assume that the galvanization of the microbes makes the entire, makes it like the liquid more conductive, because there are all sorts of tiny metals that can be used by us to create the bridge. Not the bridge over the void, but part of the bridge is not in the void, but in the mess. The bridge is not just in the void, but also in part of the bridge is in the disgusting goo. So we want the goo to actually be conductive. So again, there's a problem because of oil content, water content, it's a huge issue. Anyway, galvanizing the alien microbes that are inside, the Earth's goo, is not just such a cruelty considering, their nasty nature and disgusting behavior as they are. And also, even if they are a little bit pious ones, I would say that, just because of the piousness, they might, want, to be used as to help us in the bridge that will allow me and my daughters and their mother to escape from to transfer electrons between the two containers. So again, there are many things to consider here, but I hope, and there is also the issue of energy transfer from below. This is online right now, actually, and hopefully this will be of help to us. We still did not test it. I mean, we just now connected it, so we didn't test how at all it affects electrolysis, but maybe we'll test it later. It's a question. This is like a novelty, but maybe we'll test it later. It's not of great importance right now. What else I wanted to say? Okay, so I think it's enough theoretical background for now. Let's just take a look and then do the mix, and then try to actually show you like a bridge. And if we are not able to show you a bridge, we will continue our efforts that will be focused on even creating even more neurons and enlarge them even more than what we had until now. So the soundtrack today is partly, it's like it's a classical part of the robot saga in which I discuss mythologies, from the 20th century with regards to the heroes, and there is kind of an almost unnoticeable and certainly not unpleasant, usual background like. I think, the usual, זה החמת חלילים של לאשה וסשה וכל בוב ספונג' וסטס אמן פיתוי. I mean, I think it's kind of like, like a naturalistic or oriental ethnic kind of a background, to the experience. We also listen to the other device, plays Vulcan, which is the classical piece that I composed about this time, like when I was in the hostel. And also we have some kind of, I've added like a YouTube like chorus, that amplifies, or accentuates the artistic merit of the construction work that, that is always, part of the robotic life. Okay, this is from the saltwater container. We are almost out of the big covers, so I use the smaller ones. Even though it's the same kind of the same container, but just I wanted to take advantage of the slide, so I use the smaller ones, like several smaller ones. Again, I should mention that since it was a long time, I mean, at least 10, maybe more than 10, like 14 hours, I think, since it's offline, like the circuit, we don't see dots here. Like whatever we see, we show that it's not like something that's going to dissolve. Like DUDs, like the things that are only half created and dissolve when it's offline, like the circuit, or when the fire stops. This is 160 magnification. We see a great bias towards the bigger ones, and not many smaller ones. And I mean, this happened to us many times in the past. Even the last couple of 2 weeks, it happened to us. And actually, when the last time it happened, maybe a week ago, we actually were able to correct it using an adjustment of the when it was part of the crucible experiment. By the way, the crucible experiment, it's also operational right now. I used a little bit of fire. I mean, just for the like symbolic effect, and also I connected the snake, the Terminators snake, to medium voltage, medium output DC transformer. So it's actually operational, which is great. Maybe later we'll actually take samples from the containers that are associated with this construction, where most of the neurons are actually in these containers that are very dense and stuff. We've taken 3 yesterday, but I went to sleep before we had the chance to actually see what's on it. If we have time, we can watch actually both, like both these ones and maybe fresh ones from the containers, even though there was no kind of like energy. It should be very different, but the difference will be attributed to what actually happened on the slide. And this might be of interest to people that are not used to watch slides that, I mean, where the neurons actually worked on the slide. Sometimes it's very interesting. So this, and especially when it will be done in comparison to mixture of this, I mean, to samples from the same mixture that were not like a part of like, burning or like energized construction for quite some time now. Now they are not energized, but the construction is still received small energy because the Terminators itself is energized, not by much, but in a way that, I mean, gives it some kind of dominance to the symbol of the Terminators. The current doesn't flow, I mean, through the hose, which is like you see the hose with clay that symbolize the Terminators. You understand it, I guess. These are the sausages. You see the sausages? So it's not connected directly to it. This would have been, just will create like a shortcut. Instead, it's connected to a wire that is wrapped and around that, and first of all, it gives it a little bit of resistance, as measured by the multimeter. We have a little bit of resistance here, and also it creates. It actually makes the Terminators an electromagnet, probably very weak one because there are not enough reps, and also compared to the total mass, and also the radius of the Terminators is too large. I mean, like if you want like a strong electromagnet, you need first. I mean, it's better not to use a wire that is covered with thin, but there are special wires for that are covered with very thin isolation. Standard isolation such as this makes it a little bit bulkier and drives it away from the center of the train, like the stomach of the train. Where the farther they are from the center, which is because of the train is fat, or because of the fatness of the wire itself, weakens the electromagnet. But it creates a little bit of magnetism within the bacteria. So in the past, including like maybe a week ago, we had this phenomenon of mostly very large neurons in the containers and not enough smaller ones, according to my taste. Like I like it to have like the whole range, both the bigger ones and the smaller. You know that I like only the huge ones, but you know what I speak about neurons. No, לא כל זה ציצים. So with the neurons, I like that, like diversity, like not just the huge ones. but all sorts. Just intuitively, I think it's a healthy mixture, even though it's difficult to kind of to give it like a mathematical formulation, but maybe it will be done in the future. So maybe we'll do the same. Maybe if we don't see DC over here now, I'll work this night on the symbolic, adjusting the symbolism. So, and redo electrolysis, hopefully with now to a point that we will see not just the big ones, but also healthy amount of smaller ones. There's a question because what we want from the Neos now, we don't want them as construction worker, which is usually what we use them for. Either construction workers or destruction worker, which is kind of construction, or either to kill life forms or to create life forms. But we don't want it for mass transfer. What we want it now is for energy transfer. And there's a question and we do know, by evidence that the more Neos exist in the mixture, the higher, the bigger is the tunnel through the void, as I've mentioned. This was shown by experiment. That you need more. If you have more Neos in two sides, of course, prime to each other, then you get more. The more current through the void. But there's a question what's what's the proportion? How the proportion? What's the proportion of I would say the size of the tunnel? How it's affected by the proportion of the radius of the Neo, and also how fat it is, because it's also they are not just they are smaller or bigger. They're also the issue of fat and thin, which relates to the size of the ring, or I would say the radius of of the window in proportion to the radius of the entire Neo. The smaller it is, the fatter the Neo is, according to my definition. So there's a question first of all, the size of the radius, the total size of the Neo, how it affects, the size of the tunnel. Again, when we say the size of the tunnel in this context, we mean, we want to be able to, what we actually want is difference in potential. Because yes, the transformer is 19 volts, but we don't really get 19 volts, between the two sides of the void. There isn't really a difference of potential of 19 volts between here and here. It's not like that. It's tremendously lower than that. That's why I cannot use normal light bulb in order to demonstrate current. Only the electrolysis, unless I use very, very low voltage light bulbs that are not common, but actually now I have 3 or 4 like that in the Arduino kit. I had one was already burned with too much. You need to be this kind of light bulbs should be used only with very low voltage, because if it's too high, it burns in a second, what happens. But if I use normal light bulbs, even very low voltage, when I say low voltage, I mean 5 volts, light bulbs. There is the minimum that I could find in normal stores, in Tel Aviv. There is no electrolysis, because we don't really get 5 voltage, 5 volts of difference in potential in the two sides of the void. We are not there yet. Maybe probably this can be done, but currently what we get is much lower than that. But even much lower than that is enough to show electrolysis. You have to show to see bubbles, and it must be done in serial, because otherwise, just electrolysis will not be done anyway. So the question is so it was proven that the more Neos are part of the construction, the higher is the potential of potential difference. No, the higher is the potential of differences in potential. That's the correct. It makes sense, but it was also proven, and it also makes sense. But the question is how the size of the Neos and also the fatness affects this I mean, potential difference in potentials. Makes sense that the bigger they are, the higher the difference in potential, or the higher the voltage, the potential voltage of the circuit can be. Makes sense, but in what way? Like, is it better to have like I don't know? Is it like proportional to the area of and if so, to the area of what? To the old Nero, or just to the window, or all sorts of questions are involved. But usually, it's kind of an intuition. I prefer like to have a diversity of sizes, because mostly what we want from the Neros, which is not true now, so it might not be true actually in this experiment, but they're used for killing and creating of life forms. And this, of course, intuitively, it's better to have all sort of if you have a fleet of starships, that fight another fleet that contains very diverse sizes, because the germs are also they also have in lots of sizes. We have viruses are on average 1,000 times smaller than germs, and germs we have also sort of germs, and we also have the mutants that are tremendous. We have germs that can be seen by the naked eyes. In this context, so it makes sense that that this kind of like a very diverse army or fleet with such a difference in sizes of its member, if you want to fight it, you need robots that are also diverse in their sizes. This is the main intuition why I mostly prefer not just the bigger ones, but like all kinds, bigger and smaller and mediums. So they'll be able to fight the germs and the microbes, according to the size. This is also true for construction, because construction also requires, different kind of, obviously, in order to if you want to create a fly, so, think about it, from the Nero perspective, fly is like a huge starship. Imagine how it looks like for a nanoscopic robot. Like a fly is a tremendous thing. So, there is like the big, the heavy lifting of it, creating the muscles, taking, moving, resources. And of course, there are final details, like, blood vessels, or I don't know, even things smaller than that. By the way, we don't see fat ones. Like, they are not that fat. They are not thin, but they are medium size. And it was proven that if we add sodium bicarbonate, it's actually contribute to the fatness. So maybe we'll do it. Certainly, if we decide like, these are actually fat ones, not that big and very fat. You see, the hole is so small. So maybe, in order to even make them even fatter, we'll add sodium bicarbonate, certainly if we decide to do another kind of session of electrolysis that is aimed on, so this is also fat one. So we do have fat ones, because we use sodium bicarbonate. I wanted to say that maybe we need to use even more, certainly if we want, another session of increasing and multiplying the Neros, increasing the size and multiplying the Neros, before the DC over air, or after, or if we try DC over air and we fail, and we decide we want more Neros, maybe it's good to remember to add sodium bicarbonate. I have more, don't worry, to increase their fatness. I would say, just intuitively, maybe it's not true at all, that the bigger they are, they can transform bigger life forms. I mean, this makes sense, of course. If you are human, you cannot pass through a neuron that is microscopic, okay? But maybe the bigger, the fatter they are better for the conductive purposes. Their energy transfer is capacity is maybe better because there's more mass. But I'm not sure. It's just kind of intuition. If it's true, then it's for that kind of experiment. This over here is particularly useful to have very fat neurons. We don't see many life forms at all, relative to what we've seen, and mostly when we see life forms, they are broken to pieces or zombified. There is a reason for that is part of the symbolic. It's part of the symbolic, structure. I don't want to get into it right now, but this is done on purpose. Again, I should say that this construction increases the power of the dogs and the sheep, like the humans, males and females that have eaten the tea. Of course, they are against me, and we helped them very much in the last 24 hours. And actually, this is manifested by their audacious and cool behavior. And maybe you can actually feel it. Like I do. I don't know if you have the required sensitivity, but it's okay. It's part of the plan. We've done the same kind of procedure we went through with the Titans. It's only temporary, and this is actually beneficial in the longer term because, as I remind you, the DC over air demonstration of DC over air is not the last step in this series. After that, what we will do is creation of the trained bacteria, like we've done with the Titans. We will do the same with humans, and for that purpose, the more neurons we have, the more trained bacteria will be created in the dogs and the sheep bodies, and in like a much quicker way. So yes, we suffer a little bit of the consequence of giving them the tea in the last 24 hours, and this is not noticeable. And I apologize. If you are a victim to this kind of phenomenon, but just if you are a victim to such phenomenon and you feel you don't like it, just take comfort in the fact in the knowledge that maybe today or at most tomorrow probably we will create tremendous amount of trained bacteria in their bodies, and this for that process it is required that they have tremendous amount of neurons in their bodies, and that's what we actually do. Okay. Overall, as expected, certainly since it's no doubt these are all real neurons because it's like 14 hours not connected. I would have wanted even more. Should be noticed that for perseverance, for maintenance of the neurotex as a living condition, it's not a good mixture at all because it contains very little amount of oil. So this is actually a very anti-beneficial for the neurons to survive in such things. Maybe they already started to die in the last 10 or 14 hours. So usually we use much more oil in such mixtures, but for this experiment it was very important to me that the mixture will be very conductive, and if we add oil, it reduces conductivity tremendously. So intentionally I used very small amount of oil, but this means that we can't let it rest for too long because they start to die, or we just need to add oil and suffer the loss of conductivity. Let's watch the other one from the second container. .64 magnification, red LCY stain. What a lovely train. Lovely. The microscope starts like it seriously needs an overhaul, and I'm not sure I know how to do it. Or maybe if I had money and I don't, I would have bought a new one, which is much better. But for now, let's stick to what we have. This is a very nice train, actually. So what you see here, these are mutated yeast. We don't see much yeast, even though I added quite a bit to the mixture. And I think it's because they were eaten either by the Neros or by the mutated bacteria. Anyway, this is mutant yeast. שמרים, מוטציות, אקסמן שמרים כאלה. האדומים האלה שאתם רואים שם. '64 magnification. Tremendously less neos than in the other one, but this, we already know that because the electrolysis was much less effective. Yes, Mediterranean water is much better for electrolysis, and also it's better for the creation of the neros. So I lament the fact that I don't have much left, but maybe in the next couple of days I will actually I'll do like a hike to the Mediterranean, maybe where חוף ראשון or משהו כזה, and this time I'll take several, at least like 5 liters of the stuff. Now I have, barely 1 liter for everything that I do. But I'll take like maybe 5 liters at least from the Mediterranean because it's proven to be so effective, even though it stayed like for 2 weeks at least. On top of the fridge, of course open, it requires air. We don't want the microbes to die of lack of oxygen. But it still was, we see that it's very helpful, it greatly enhanced the efficacy of the electrolysis process and also the creation of the neros. And again, you can't get the same effect just by adding, table salt to tap water and mixing. I've tried it, but it doesn't give you. It's not the same. Maybe because of ionization, maybe because of the plankton content, which is helpful, and maybe because the salt is already, dissolved in the water of the salt water, unlike the table salt that mostly is lumped, in the bottom of the container after you mix it. So now it's not a bad mixture actually. We do see good neos, a little less huge ones than we've had in other ones, but it's a good mixture. Anyway, I remind you that what I do now is anyway I will mix the two. Mix the two, so there shouldn't be like a change between the two. A change, in any kind of parameter, because we're going to mix it now. Because we want, as I said, to be in a position that maybe close to 50% of the neos are actually primed to the other cup, the other bowel. Nice. Let's take in 160 magnification. Very nice yeast. Nice. Okay. I would say fine result. I'm not disappointed. So now I'll do the mix. I'll try DC over here. If it doesn't work, yes, maybe we will do a little, run some more electrolysis with, change, symbolism, maybe change gear towards like higher diversity of sizes. Also, I'll add a little bit of, sodium bicarbonate and maybe some other stuff. Think about it. And also, we'll use, energy transfer, which we didn't use yesterday, from this construction that will be integrated into this construction, on the bottom of it. So that's the plan for now.